Several potential code violations exist in this pool installation. Firstly, according to National Electrical Code Section 680.20a, the pool should have a dedicated circuit and not be shared with the air conditioning unit. Secondly, National Electrical Code Section 680.22b states the circuit supplying the filter motor should be at least 20 amps. Thirdly, National Electrical Code Section 680.7a specifies that the ground fault circuit interrupter receptacle should be of the weather resistant type. Fourthly, National Electrical Code Section 680.7c indicates the ground fault circuit interrupter receptacle should be listed for outdoor use. Fifthly, National Electrical Code Section 680.7d requires the ground fault circuit interrupter receptacle to be accessible but not directly above the pool. Sixthly, National Electrical Code Section 680.24a mandates a pool should have a bonding grid or an equipotential bonding system. Seventhly, National Electrical Code Section 680.24a specifies all metal parts of the pool, including the pump, filter, and ladders, should be bonded to the bonding grid. Beyond code violations, additional safety concerns arise from the lack of a proper disconnect for the pool equipment, the exposed wires and terminals at the ground fault circuit interrupter receptacle, and the potential for tripping over the underground wire due to its shallow depth. Overall, the pool installation is clearly not up to code and poses significant safety risks. It's recommended that the house not be purchased until these violations are addressed. A qualified electrician should be hired to rewire the pool and bring it into compliance with the National Electrical Code. Addressing the specific concerns, firstly, the 12/2 with ground wire being supplied by a 30 amp breaker violates National Electrical Code Section 240.4d, which limits the overcurrent protection for 12 gauge copper wire to 20 amps. Secondly, the installation appears to violate National Electrical Code Sections 680.30 and 680.10, which pertain to the wiring methods and grounding requirements for pool equipment. The use of underground feeder cable directly buried within 5 feet of the pool walls does not provide sufficient physical protection for the wiring. Rigid non-metallic conduit is a more suitable option in this situation. Thirdly, the placement of the receptacle outlet violates National Electrical Code Section 680.34 regarding the location of receptacles near a pool. Receptacles serving pool equipment should be located at least 6 feet from the inside walls of the pool unless they are ground fault circuit interrupter protected and provide a cord and plug connection for the equipment. Considering the National Electrical Code requirements for a storable swimming or wading pool, several factors must be considered to ensure safety and code compliance. The following explains these requirements in detail. Firstly, the definition of a storable swimming or wading pool is found in National Electrical Code Section 680.2. It is defined as a pool that is intended to be disassembled for storage and typically has a maximum depth of 42 inches. Secondly, Section 680.20 of the National Electrical Code addresses the branch circuit requirements for pool equipment. It requires that pool equipment be supplied by dedicated branch circuits. This means that the pool equipment cannot share a circuit with other loads such as air conditioning units. Thirdly, Section 680.22b of the National Electrical Code specifies the minimum ampacity requirements for the branch circuit supplying the pool filter motor. It requires that the circuit be rated for at least 20 amps. This is to ensure that the circuit can handle the load of the motor without overheating. Fourthly, Sections 680.7a, c, and d of the National Electrical Code cover the requirements for ground fault circuit interrupter protection for receptacles serving pool equipment. The receptacle must be weather resistant, listed for outdoor use, and accessible but not directly above the pool. Fifthly, Sections 680.24a and 2 of the National Electrical Code address the bonding requirements for pools. Bonding is the process of connecting all metal parts of the pool and its equipment together to create an equipotential plane. This helps to prevent electric shock hazards. A bonding grid or equipotential bonding system is required for all pools, and all metal parts of the pool, including the pump, filter, and ladders, must be bonded to this grid. Section 240.4d of the National Electrical Code provides specific guidelines for the overcurrent protection of conductors. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect conductors from overloads and short circuits. The size of the overcurrent protection device must be matched to the ampacity of the conductor. Using a 30-amp breaker to protect a 12-gauge wire is a violation of this section. National Electrical Code Sections 680.30 and 680.10 outline the requirements for wiring methods and grounding for pool equipment. These sections require that wiring be installed in a manner that protects it from physical damage and corrosion. Wiring must be grounded properly to provide a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electric shock. National Electrical Code Section 680.34 specifies the requirements for the location of receptacles near pools. Receptacles must be located at least 6 feet from the inside walls of the pool, unless they are ground fault circuit interrupter protected and provide a cord and plug connection for the equipment. This is to prevent people from using electrical appliances near the pool, which could create an electric shock hazard. When a service panel is replaced, the question of whether the house should be brought up to current code is complex. The answer depends on several factors, including firstly, the local codes and regulations. Some jurisdictions require that all electrical work, including service panel replacements, must comply with the latest edition of the National Electrical Code or Local Electrical Code. This means that the entire electrical system may need to be brought up to code when the service panel is replaced. Secondly, the extent of the work being performed. If the service panel replacement is part of a larger renovation project, the local building department may require that all electrical work comply with the current code. However, if the service panel is simply being replaced in kind, without any other electrical work being performed, the requirement to bring the entire system up to code may be less stringent. Thirdly, the age and condition of the existing electrical system. If the existing electrical system is old and in poor condition, it may be necessary to bring it up to code when the service panel is replaced. This is because an old and outdated electrical system may not be able to handle the increased load of a new service panel. Fourthly, the specific requirements of the National Electrical Code. Some sections of the National Electrical Code require that certain electrical components or systems be brought up to code when they are replaced or upgraded. For example, if the service panel replacement involves replacing the grounding electrode system, the new grounding electrode system must comply with the current code. Generally, it is always a good idea to consult with a qualified electrician or local building official to determine whether the house needs to be brought up to code when a service panel is replaced. They can assess the specific situation and provide guidance on the applicable codes and regulation. Even if it is not required by code, upgrading the electrical system to meet current standards can improve safety and reliability. In cases where a service is being upgraded, such as from 60 amps to 100 amps, local codes often mandate that the entire electrical system be brought up to current code. This is because an upgraded service can place a greater load on the existing wiring and components, which may not be able to handle the increased current. Therefore, it is essential to ensure that all electrical work is performed by a qualified electrician and that all applicable codes and regulations are followed. The identification of additional missing elements. Firstly, ground fault circuit interrupter protection. Evaluate whether all required locations have ground fault circuit interrupter protection, particularly receptacles within a certain distance of water sources, bathrooms, kitchens, and outdoor areas. Secondly, arc fault circuit interrupter protection. Determine whether arc fault circuit interrupter protection is required for branch circuits supplying dwelling units, as mandated by the National Electrical Code. This is important for preventing electrical fires. Thirdly, smoke alarms and carbon monoxide detectors. Verify the presence and proper placement of smoke alarms and carbon monoxide detectors throughout the house, in accordance with local codes and National Electrical Code requirements. These devices are crucial for life safety. Fourthly, grounding and bonding. Inspect the grounding and bonding system to ensure it is properly installed and connected. This includes the grounding electrode system, equipment grounding conductors, and bonding of metal parts. Proper grounding and bonding are essential for preventing electric shock hazards. Fifthly, conductor ampacity and overcurrent protection. Review the conductor sizes and overcurrent protection devices to ensure they are properly matched. Conductors must be sized to carry the intended load, and overcurrent protection devices must be sized to protect the conductors from overloads and short circuits. Sixthly, wiring methods. Assess the wiring methods used throughout the house to ensure they comply with the National Electrical Code. This includes the type of wiring, the method of installation, and the protection of wiring from physical damage. Seventhly, box fill calculations. Check the electrical boxes to ensure they are not overfilled with conductors. Overfilled boxes can lead to overheating and fires. Box fill calculations are used to determine the maximum number of conductors allowed in a box. Eighthly, appliance circuits. Verify that major appliances, such as ranges, dryers, and air conditioners, are supplied by dedicated circuits with the appropriate voltage and amperage ratings. Ninthly, lighting fixtures. Inspect the lighting fixtures to ensure they are properly installed and supported. This includes ensuring that the fixtures are securely mounted and that the wiring is properly connected. Tenthly, labeling and identification. Confirm that all electrical panels, circuits, and equipment are properly labeled and identified. This helps to ensure that electrical systems can be easily understood and maintained. In the given scenario, sharing a 30 amp breaker between the pool filter motor and the air conditioning unit raises several concerns from an electrical engineering perspective. Firstly, overload potential. Air conditioning units and pool filter motors both draw significant current, especially during startup. Combining these loads on a single 30 amp breaker increases the risk of overloading the circuit, causing the breaker to trip frequently. This is not only inconvenient but can also damage the equipment over time. Secondly, code violations. The National Electrical Code typically requires dedicated circuits for major appliances like air conditioners and pool filter motors. This is to ensure that each appliance has sufficient power and that the circuit is not overloaded. Sharing a circuit violates these code requirements and can create a safety hazard. Thirdly, voltage drop. When multiple appliances are connected to the same circuit, the voltage can drop, especially when both appliances are operating simultaneously. This can reduce the efficiency of the appliances and can even damage them over time. Fourthly, safety hazards. Overloaded circuits can overheat, which can lead to fires. Additionally, sharing a circuit between a pool filter motor and an air conditioner can create a potential shock hazard, especially if there is a fault in the wiring. The use of 12/2 underground feeder cable for direct burial application raises several concerns. Firstly, ampacity limitations. 12-gauge wire has a limited ampacity, typically around 20 amps. Using it on a 30 amp circuit violates the National Electrical Code and can cause the wire to overheat, leading to a fire hazard. Secondly, physical protection. Direct burial underground feeder cable is not as well protected as wiring installed in conduit. It is more susceptible to damage from digging, rodents, and other environmental factors. Thirdly, grounding. The grounding conductor and underground feeder cable may not be adequate for providing proper grounding for pool equipment. This can increase the risk of electric shock. Fourthly, code compliance. The National Electrical Code has specific requirements for the type of wiring that can be used for direct burial applications. Underground feeder cable may not meet these requirements, especially near a pool. The installation of a ground fault circuit interrupter receptacle with a broken cover near a pool is a serious safety hazard. Firstly, electric shock risk. Water and electricity do not mix. A broken cover on a ground fault circuit interrupter receptacle exposes the electrical terminals to moisture, which can create a path for electricity to flow through the water, posing a significant risk of electric shock to anyone in or near the pool. Secondly, ground fault circuit interrupter protection compromised. A broken cover can also compromise the ground fault circuit interrupter protection itself. The ground fault circuit interrupter may not function properly if it is exposed to moisture or debris. Thirdly, code violations. The National Electrical Code requires that all electrical equipment used near a pool be in good working order and properly protected from the elements. A ground fault circuit interrupter receptacle with a broken cover violates these requirements. Fourthly, accessibility. The ground fault circuit interrupter receptacle should be readily accessible for testing and maintenance. A broken cover can make it difficult to access the receptacle and can also make it more likely that the receptacle will be damaged. The appropriate wiring method for a pool depends on several factors, including the location of the wiring, the type of pool, and local codes. However, generally speaking, rigid non-metallic conduit is the preferred wiring method for pool applications. Firstly, physical protection. Rigid non-metallic conduit provides excellent physical protection for the wiring, protecting it from damage from digging, rodents, and other environmental factors. Secondly, corrosion resistance. Rigid non-metallic conduit is resistant to corrosion, which is important in pool environments where there is a lot of moisture. Thirdly, grounding. Rigid non-metallic conduit can be used with a separate grounding conductor to provide proper grounding for pool equipment. Fourthly, code compliance. Rigid non-metallic conduit meets the requirements of the National Electrical Code for pool wiring. Other wiring methods that may be used for pool applications include electrical metallic tubing and liquid-tight flexible metal conduit. However, these wiring methods may not provide the same level of physical protection as rigid non-metallic conduit. In certain circumstances, underground feeder cable may be permitted for direct burial applications, but only if it meets the requirements of the National Electrical Code and is installed in a manner that protects it from damage. The location of a receptacle outlet near a pool is governed by specific National Electrical Code requirements. Firstly, distance requirements. The National Electrical Code requires that receptacles be located at least 6 feet from the inside walls of the pool. This is to prevent people from using electrical appliances near the pool, which could create an electric shock hazard. Secondly, ground fault circuit interrupter protection. If a receptacle is located closer than 6 feet to the inside walls of the pool, it must be ground fault circuit interrupter protected. This will help to protect people from electric shock if there is a fault in the wiring. Thirdly, accessibility. Receptacles must be readily accessible for testing and maintenance. However, they should not be located directly above the pool. Fourthly, dedicated circuits. Receptacles serving pool equipment must be supplied by dedicated circuits. This is to ensure that each appliance has sufficient power and that the circuit is not overloaded. In summary, the installation has several code violations that require immediate attention from a qualified electrician.